All right, so let's look at some ways that we can prove figures similar using the criteria that we've established in previous lessons. So we know that figures are similar when corresponding angles are equal and when corresponding pairs of sides have proportional lengths. In other words, the scale factor is the same for all pairs of corresponding sides. So we can tell if two triangles are similar without having to know all three angle pairs and all three side pairs. We can do it with some shortcuts. So using similarity transformations, we'll take a look at each version. So exercise 1, if we're given these two triangles ABC and DEF, we know that angle A is the same as D, angle B is the same as E. Could we give a dilation of triangle ABC that would make the image congruent when we do that procedure? So if you dilate around point A by a scale factor of DE over AB, then the images would be the same. So if you just take the larger one and divide it by the smaller one, we establish a scale factor. Would that dilation change the angles? It never changes angles. Dilations keep angles the same. So why would they be congruent? Well, now we have two equal angles, and we would also have side lengths congruent after dilation. So because the triangles would be congruent after dilation, they must have been similar to start with. The other way to think of it as a shortcut is if A and B are the same as D and E, then their sums are the same, and both triangles would have the same amount of degrees remaining for C and F. And so by triangle sum, all three angles would be the same as well. And that's a way to say that those triangles are similar as well. So there's a criteria called angle-angle. In congruence, if all we had was angles, we said that it wasn't enough information because it could be a dilation. Well, now here we are with dilations. So if we have two equal angles, we can say for sure that the triangles are similar and a dilation has occurred. Now, maybe that dilation is scale factor 1 and they're actually congruent to each other. But what we know is that there's been some kind of dilation, so we can prove similarity. So in exercise 2, we have parallel segments here. We can prove that they're similar because if they're parallel, angle 1 and angle 2 would be congruent since they're corresponding. And angles 3 and angle 4 would be congruent because they're corresponding. So that's two equal angle pairs, and we'd have similarity for that reason. We would say a code, if we're making a formal proof, the code would be AA. If we're writing it out, you can paraphrase however you wish, but somehow get it down that because the lines are parallel, corresponding angles are equal, and we have now two pairs of corresponding sides, or corresponding angles. So in that above diagram, if we put an 8 on segment MQ and a 6 on segment NQ, and then NP is 21, could we figure out the length of QR? Well, if I have an 8 and a 6, then I can do this with proportions, and that will work. But I think we can also establish a scale factor if we wanted to. We can say that the scale factor is 14/8 because the full length of segment MN would be 14 and the partial length would be 8. So the scale factor is going to be 14/8. But to show, I think a proportion works just as well too. QR relates to NP as the bases of these triangles in the same way that MQ relates to MN. So it's just showing the larger or the smaller over the larger in each case. So if we just put in the segments that we know, then we can do a cross product and solve it. But we also could take that 21 and apply the scale factor, which going from large to small would be 8/14. Either way, we can get QR equals 12. And we'll work with that extensively in class, both using proportions and using scale factors. All right, so the side criteria for similarity and the side angle side criteria for similarity are pretty close to each other. And what they say is something very close to the congruence codes. We had SSS and SAS in congruence, but those required the sides to actually be equal to each other. Now we're saying that the sides in question have to be the same scale factor with each other, or proportional, however you want to say it. So if I'm looking at exercise 4 in part A, what I would want to confirm is that all the corresponding sides divide out to the same scale factor. So if I take the corresponding segments, DF and AC, again checking that they're in the same positions in the names, those should divide to the same scale factor as every other pair of corresponding sides. So if I take DF over AC and ED over BA and EF over BC, every time I'm getting the same scale factor of 2. And so that's going to be considered SSS similarity because they all come out to the same scale factor. Again, they don't have to be equal. They just have to be the same scale factor. Another way to think of it without having to look back at the names is the smallest side of both triangles, the medium side of both triangles, and the largest side of both triangles all have to divide out to the same thing. So just check for matching that way too. That'll work as well. In part B, we have 220-degree angles. So that's the angle part of SAS. So in order for this to work, the shorter side of ABC should match up with the shorter side of DEF, and the longer side should match up with the longer side. When I say match up, I mean that the scale factors should be the same. So, and I'm saying to match, I'm stressing this to match short to short and long to long because, again, there can be a rotation or a reflection so that the orientation on the page tricks you. So just find it so that it matches up perfectly and divide to check. So 15 divided by 10 gives you 1.5 and 21 divided by 14 gives you 1.5. But had this been reflected, you might have been tricked into thinking 21 matches with 10 and 15 matches with 14, and you would say the scale factors don't match. So just be careful that you get the corresponding sides when you're checking for scale factor. So we have SSS and SAS to go along with AA. Exercise 5 to finish up here. In this diagram, we're trying to figure out which is not sufficient to show that there's similarity. So looking at choice 1, if I take RS and AB, those match. Those are the short and the short. ST and BC are the medium and the medium. And TR and AC are the long and the long. They also match within the names. So if all three of those divide to the same scale factor, in other words, if they're all equal, then we have similarity. Number 1 is simply stating the criteria for SSS. So number 1 is correct. That's enough information. In number 2, if I take AB and RS, that's short and short. AC and RT is long and long. In order for SAS to work, the equal angles need to be the ones between those two. AC and RT, sorry, I said that wrong. And in fact, angle A and angle R are the ones that are given to be equal. So that works, that's SAS. So just like with congruence, the angle needs to be between the two sides that are marked or given to you in order for SAS to apply. In part 3, do we have corresponding angles? I think we do. We have S and B, and we have C and T. Those are in the same positions in the names, and so that's enough for angle, angle. Number 4 is the one that's incorrect because of the way it's arranged here. So if I take RT with AC, that's the long side and the long side. So those match. TS and CB are the medium and the medium, so those also match. So the two side pairs are fine. All that's corresponding. Angle B and angle S are corresponding angles. The problem is those two angles are not between the two sides that we've established. Remember, we established AC and BC with RT and ST. So what we needed here was angle C and T, not angles B and S. It's just the wrong angle. This would be an SSA, which is not enough for similarity. So that's the reason why choice 4 is the one that is not enough info.